Okay. So now for binary search. So this one's a little more fun, right? Okay. So again, we can just take the parameters that we set up here, and we can put it here. And we're going to unhighlight. Okay, great. Now we're ready to start coding. Okay, and so if we go back up here, we can see that we're missing some of these these basic variables that we need for this. So I'm missing a middle, a lower, and a higher. So we should probably start by declaring some of them. So we can say int lower. And so right now we haven't searched the array at all, so we can assume that the lower bound is the lowest bound, so 0. And the same with higher. We can assume that int higher will be equal to the highest bound, or size minus 1. Okay, and so now you may be thinking, oh yeah, let's make the middle variable. Except the middle is going to be constantly updated, so you should probably hold off on the middle variable until after we've implemented our loop. Okay, and so now we gotta decide what kind of loop we want. Okay, so now if you're thinking, oh, it's an array, so we gotta have a for loop. Great thought, really, like, good job, proud. But we are actually not going to be stepping through each element in the array this time. So we're going to we cannot use a for loop. We'll have to use something else. And so if we know we can't use a for loop, let's look at our different options. So our only two options are a while loop and a do while loop. And so you could use either one within the context of this, because you're going to search the array at least once probably, unless the size is 0, in which case is a special case. Like you may even want to, you can probably throw in like a if size equals 0, return -1, right? Because there's nothing there. Else else if there's only one thing, if if array 0 is equal to value, return 0, else return 1. And you could probably even do a special case for if the size was 2, but using the loop will also be fine. Okay, so we'll stick with a while loop though. And so okay, and so now we got to think about what our condition will be. So I actually said it when describing what a binary search is, but let's think about this for a second. So let's go back to our example actually, without showing you the answer. So this one, perfect. Okay, so let's say we were looking for the number 7, right? So we'd start off at 0 and 3, and we would get like 1.5, right? So then in search 4, we'd be like, oh, well, 4 is less than 7, search the top half. So then it'd be like, low is 2, high is 3, so middle would be 2.5 or 2. Compare this, be like, oh, well, 6 is less than 7, so compare the top half, right? So the higher half, sorry. And then so it'd be, okay, so low is 3, high is 3, middle is 3 as well, and so 7 is going to be less than 8, so it's going to be like, oh, search the lower half. And so basically the lower value will remain 3, while the higher value remains 2. And so when you see that they are no longer, when the lower value is no longer less than the higher value or equal to, right? That's when it breaks. Okay, now let's code the while loop. Okay, so now we got our like loop going, but we still need to like do everything else. So let's find the middle, right? Because we're still missing that. So we can say middle is equal to the average of the lower and the higher, right? So lower plus higher by 2. And in all actuality, we should probably want the parentheses around these. Okay, great. So now that means that this is going to update every time, right? And so now we got to compare the if statement, right? And we got to compare array of middle to the value. Okay? So if the array is greater, we show it equal to, right? If it's equal to the value, then we want to return middle, right? Because that's going to be our index to be used. Okay. Else if array of middle is going to be greater than the value. Okay. Else if array of middle is greater than the value, that means that the number in the array was bigger than the number we're searching for. So if it's an ordered array, right, which is the only time you can use binary arrays, that means you got to search the lower half. So if we're searching the lower half of the array, then your lower value should not change, but your higher value should become 1 less than the middle, right? Because we already checked the middle value. There's no need to check the middle value again. No, we didn't even need brackets for that. Okay, and then else, right? In the only other case, if it's not equal to and it's not greater than, it has to be less than. So that means that our value is in the higher half of the array. So that means we need to move the lower bound. So the lower bound will become middle plus 1 in comparison to where higher value becomes middle minus 1, lower value becomes middle plus 1. Okay, and then so now if it doesn't find it, then that means there's nothing there, and it should break this loop, which means that we should have a return statement out here just in case, return -1, where it's not in the code. Actually, you don't need to put this. This is like special cases. But even if you don't have this, if size is equal to 0, lower will be 0, higher will be -1, right? So this is going to be false already, and it's going to return -1. And like if it was 1, it'd work out, right? Because lower would be 0, high would be 0. It checked middle. If it wasn't there, then either the higher or the lower would be updated, which would make this false, and then it would turn -1. So this is not necessary, it just allows it to run faster sometimes. Okay, and that's essentially how you code binary search. And so now you like could put this in main, but it's just a little complicated. It's just a little complicated to put in main, so I probably wouldn't put it in main. Okay, and last but not least, let's write a program that searches an array with the numbers 1 through 10 ordered, call linear search, and use a counter variable to see the number of iterations and put it out, and we're going to do the same with binary search. Okay, so now you can see I'm on OnlineGDB, and I put the prompt up there. I have all the goodies, like including IOStream and using namespace, std, and main and stuff. And so I can actually go back and what we'll do is we'll copy what we wrote from the earlier questions. So right here we can have linear search. And right here we can have binary search. And so now we should be able to use those variables, use these functions to our liking. Okay? And so now we said we needed an array of numbers 1 through 10, I believe. So that's gonna size of 10, maybe. So now what we'll need to do is let's have both of them search for the number 7. So now we'll see out linear search says 7 is in index, and then we'll call linear search. And we'll pass it the array, the size of 10, and the variable 7. Our searching 7. Okay. And then we'll do the same for binary search. Oops. Binary search says 7 is in index. And so we'll call binary search, pass the array, the size, and the value we're searching for. Okay, and so now we will call both functions. We should but this part also says to use a counter variable to see the number of iterations and print it out. So for this, we should change it within the functions themselves. So usually you won't have this counter variable, but I wanted to put this in and show y'all to see the difference in the number of iterations. So we'll have int counts equal to 0, and then just every time the for loop runs, we're going to want it to increase by 1. And so I put it in the beginning, right? Because if I put it in the end, if it hit this and hit the return statement, it wouldn't go to the end, and so it would be 1 iteration short. And then what I'll do is here, if this is true, I'll just expand this if statement, and I'll have it print out linear search iterations equals, and we'll print out count. Oops. Okay, and now we're going to do the same thing for binary search, which means we're going to need another integer, set it equal to 0 as well. And so for the sake of this, we're going to take this out because those won't have any iterations, right? So we'll have count increase here, and then we'll do the same thing, expand this if statement. Print out count in the line. Close bracket. Okay, great. So now it should get to print out what we want. So let's run the program and see what happens. Okay, there's a compilation error. So any programming starts with a compilation error, so that's okay. So let's jump to the problem. Oh, I'm right here. And see what it. Oh, okay. So it's just it didn't like that I copied it from Word, basically. Yeah, that was my only issue. Anyway, so the linear search iterations make 7, which, can be true. 7 is found in index 6, true. Binary makes 4, and binary says 7 is in index 6 as well. So let's go check that out. So obviously 7 is going to make 7 iterations. Binary search, though, it'll do, so 0 plus 9 is going to be 9 divided by 2 is going to be 4.5. So it's going to search index 4, which is coincidentally 5, right? 5 is less than 7, so we're going to search the higher half. So that means it's going to make it 0, 1, 2, 3, 4, 5. So it's going to make the lower index 5 and the higher index 9. So 5 plus 9 will result in 14, divided by 2 is 7. So index 7 will be 8. And so 8 is going to be less than 7. This is on a third iteration, right? And then so it's going to move 9 to 6 because we already checked 7, which was 8. And then so a lower index was 5. So it'd be 5 plus 6, which is 11 divided by 2. So it's 5. So then it'll check this one. It'll check 6. And then it's going to be greater than. So it's going to move the lower value up to 7. And then it'll find the equal, and it'll be that. So that will be 4 iterations, right? Because we did one whole one where it checked 5, another one where it checked 8. So that's 2. One where it checked 6, 3, one where it checked 7. Yeah, so 4. So so if you're doing an array and its values 1 to 10, just be careful not to get them mixed up with the indexes. But yeah, so that's essentially how the array works. Now let's say, like, what if you had a bigger array, right? Let's say we had an array of 100, okay? And I'm not going to initialize that all, right? But what we'll do is we'll put in a quick little for loop for int I is equal to 0, I is less than 100, I plus plus. And then we'll just say array of I is equal to I plus 1. Okay, great. And so this would be numbers 1 through 100. And so let's say instead of 7, we'll search for 77. Can y'all tell I like the number 7? Anyways, so we'll search for 77, and then let's see what happens this time. Okay, so this time it just didn't work. Oh, we forgot to change our sizes. Also, we forgot to put a return value in case they couldn't find it up here. So we're gonna have return -1 up there. So now it's gonna work. Okay, yeah, so now you can see that there's 77 iterations in linear search, and is found in linear ends index 76, but in binary search it only makes up. So 77 versus 7 is a big difference, and it can get, even higher, the difference, depending on how, if the array is bigger, like, right? If it's an array of like 1,000, right? It'd be way bigger. Yeah, and then so that's essentially how you do binary and linear search, and that's how you can really see the difference in their efficiencies. Also, there's one more thing I would like to show y'all. It is this website. I will give out this link somehow, whether it's either in the description or in the email I send out. So this kind of shows you how linear search and binary search work as well. So it can give you, like, you can either pick a small list or a large array or a large array. We're gonna go with small because large was too big for us. And so we can pick a number that we want. So let's pick 363, index 12. And so I'll slow it down a bit. And so let's do a linear search first. And so you can see that it goes through each one, it checks the value in comparison to the number, and it just keeps on going and doing its thing all the way till it hits the index and it finds it, and it returns the result. Okay, and then so let's say we do a binary search now. Okay, so you can see here it picks the smaller value in blue, the biggest value in orange, and the middle value in green. after it does the math, and I'm going to slow it down just a little bit so you can see. And then it checks the middle in comparison to what it finds. It found that it was the value was bigger, so it moved its middle, it moved its high, and then it was smaller, so it moved its low. And so, yeah, you can just see how it's working. And so, in this case, finally it finds it there. But you can still see how that's faster than the smaller, so then linear search. So, especially with something like this, I'll show you with like 600 real quick, and I'll make it do binary search, but I'll make it go like a little faster. So you can see how it cut out all of that immediately, and you can see how it just cuts out like a bunch of elements each time that it searches, in comparison to linear, where it would have taken 110 comparisons. Yeah. Well, if you have any questions, y'all feel free to stop by my office hours, and don't forget to fill in the attendance form if you haven't already. Thank you all for making it all the way through this video. Here's a little way of saying thank you.